Great. All right. Thanks a lot, everyone, for joining us. My name is Mike Deck. I am a Principal Solutions Architect at AWS. And I'm going to be talking to you today about event-driven architectures and dive into some of the new features of Amazon EventBridge. So if you're like me, you spend a lot of time thinking about event-driven architectures in your free time, and you start seeing a lot of these patterns show up in different parts of your life that you might not have originally thought of. So I thought I'd share a little story with you about my own personal life that I think illustrates some of the concepts we're going to be talking about today. So how many people here have kids? Anyone kids? Anyone have young kids, like toddlers, little kids? Okay, I've got a couple of young sons, and my wife and I take them to this gymnastics class every week, and they love going and you know, jumping and tumbling around and everything, but getting them out of the house is always a bit of a challenge. It never goes exactly the way I expected it to. The way that I would like for things to work is, you know, I say to my sons, okay, boys, it's time to go to Little Gym. And they say, okay, Dad, that sounds great. I'll go get my shoes on, get my jacket, jump in the car, get my seatbelt on, and we're ready to go. But it never happens like that. Instead, I have to walk them through every individual step. I got to say, hey, you know, Matthew, go find your shoes. Can you go find your shoes? So he runs off to go find his shoes, and then, of course, never comes back. And so I've got to go run off and figure out where he went, what happened with him. You know, finally find the shoes, I find him, say, okay, we got to put your shoes on, right? No, I don't want to, not interested, right? I try it again. Come on, buddy, got to try it. We got to get your shoes on, got to get ready to go. No, I'm playing, I got other things going on. That's all right, I've got a retry policy. No problem, I can try this one more time. You know, hey, come on, let's get your shoes. Got to have them to go. Absolutely not. He's not interested in it. At this point, my operational KPIs on the service are going in the red. We've got major problems going on, but I still got to get his shoes on, try the service one more time. Things melt down. We got to go reboot it, call in, you know, Sev1 ticket to mom, go and get the ops escalation, right? And so the problem here is that I'm having to make these individual commands and send them to this service over and over again. I, as the producer, am responsible now for the retry policy. I'm responsible for service discovery. I'm responsible for all of these different things. Wouldn't it be nice if I could just announce to my household, hey, it's time to go to Little Gym, and everyone in the household hears that notification and then goes and does whatever it is that they need to do in order to get things done. That becomes a much, much more resilient and robust and reliable system, right? So I'm sure that any of you who raised your hand originally have probably been through something like this, but I'm guessing that a lot of you who own services and run them in production have probably also seen things like this, right? You get a retry storm because a little problem starts. Upstream clients start hammering an API because they can't get the answer that they want. They retry over and over again, and eventually that brings things down, right? So that's kind of what we're going to be talking about is what are some techniques, what are some specific things that you can do to apply event-driven architectures to your own systems in order to make them more robust, more resilient, get them out of the terrible twos, and help them to grow up, right? So, you know, like I was talking about, there's a number of different benefits to building event-driven architectures and organizing your systems this way. One of the things that we just kind of were talking about is this ability to scale and fail independently. So you can build components now that are inherently decoupled so that when you have problems or when you need to scale them, they can scale independently of one another. So a failure in one component isn't going to affect the other. Building an event-driven asynchronous communication between those components really helps to enable that type of resiliency. Also, it helps with your ability to develop more quickly, to build with more agility, because now, again, because those services are decoupled, development teams can go and build new implementations and new services that are going to consume these events without necessarily having to coordinate across different teams to make sure that, okay, we're going to expose this, you know, this API for you to call, and now you need to call it before we can roll it out. It allows you to go out and build things in a more independent manner. Another benefit that I think is often overlooked is the ability to audit event-driven systems. So if all of the changes that happen to your system, if all of your state transitions are captured in these events, it becomes very easy to just archive off this stream of events so that now if someone asks you, you know, why is account 123 in this particular state, you can go back and look and say, well, here's the list of events that happened. Here's why we're in this position that we're in. So being able to go and create this audit log stored off, whether that's for compliance reasons or whether it's just for your own kind of operational debugging, et cetera, is a really nice kind of side effect of building applications with this type of architecture. And then the last piece is cost optimization. So moving to an event-driven architecture allows you to start taking advantage of services like Lambda. You don't have to pay for all of this compute to sit around idle, waiting for work to do. You can start only paying for what you need, right? Get the capacity that you need when you need it based on the events. So given all of these different benefits, I want to talk a little bit about what are some of these kind of specific decision points as you're moving towards an event-driven model that you're going to have to make. What are these decisions you're going to make, and what's some guidance for how can you kind of adopt these things more quickly? And then we'll take a look at actually building kind of an event-driven service using EventBridge and how that works with some of the new features that we just rolled out. So the first bit of advice I have around building event-driven architectures is you need to start with the domain. So start actually modeling the applications themselves around the events that you need to handle. So try to understand what are the events that exist within the business context that you're trying to solve, not just thinking about events from an infrastructure perspective. So events need to be things like, hey, a new order was created, a new user registered, not necessarily, oh, an object showed up in S3 or an item was added to DynamoDB. That might be sort of the implementation of how that event gets manifested in the system, but you should be modeling these things and thinking about requirements in terms of business events as well. So one of the techniques you can use to do this is something called event storming. I don't know if anyone's kind of heard of this. This is a technique out of the domain-driven design community. I'm not going to get too deep into it, but basically the idea here is when you're developing the requirements for a system, you work with your subject matter experts to define what are the events, what are the actors, what are the different processes, put them up on a board with stickies, and you start to cluster together related concepts. And then this allows you to now draw kind of subdomains and bounded contexts that become the services that you need to go and write. And so now you get this really nice feature, which is the requirements that you've developed, the domain model that you've now built, has kind of built in the events that serve as the inputs and outputs for each of these services that you're building. So I think that's one of the really important steps that oftentimes we kind of overlook because we tend to be at AWS really focused on kind of the infrastructure components and the broader kind of architecture, and so we just draw a lot of lines between boxes without talking about exactly what goes inside of those boxes. But when you're really trying to do things from an event-driven perspective, making sure that the event-orientedness kind of permeates inside of those boxes themselves is really important to do. So let's say you're building these event-driven applications. Next thing you're going to have to do is pick an event router, right? We got to figure out how are we going to get events from producers to consumers. Now you might be asking, why do I need an event router in the first place? Well, I've got producers, I've got event producers, I've got consumers. Why can't I just send events directly from the producers to the consumers? And this works, so you can certainly do this. HTTP is a well understood protocol, lots of support for it. But the problem is, as you start to scale up and you get more nodes in your graph, things get more and more complex. And the complexity of this system starts to grow non-linearly with the number of producers and consumers that you're creating. And I would say anytime you see a diagram that looks like this, where you've got all of these connections kind of going point to point, you've got a problem. You need to simplify that because that's going to be really hard to kind of manage and reason about long term. So the obvious sort of solution to that is put something in the middle there to mediate all of these connections and help manage that, right? So this does a couple of things. One, it allows your producers to not have to worry about sort of discovering all of the different consumers, not have to worry about subscription registration and managing that, all of those failure retries that kind of we talked about at the beginning. You don't have to deal with that anymore on the producer side. And similarly, the consumers now, or at least in the delivery phase of working with the consumers, you can offload all of that now to this kind of managed service that's sitting in the middle. Now, if you've worked in kind of a traditional enterprise environment historically, this type of model can be kind of scary to some extent because in a lot of cases, that big pink box kind of represents a single point of failure, a choke point within your architecture. And that was certainly true back when, these types of event or message buses represented a single piece of hardware sitting in a data center that, if you needed to scale up, if you all of a sudden got twice as many events as you got yesterday, I got to go and put a new piece of hardware in there. That's going to take me several weeks to actually provision, et cetera. If something fails, whether or not I'll be able to fail over quickly is kind of not necessarily a given. But now in sort of the cloud context, being able to leverage managed services to do this, even though this is one box that's really sort of representing something that's a highly distributed system across multiple pieces of hardware, across multiple geographic locations even, that's highly redundant and scalable, you're not worrying about having to scale that. You're not worrying about kind of having to manage the high availability of that component. And so moving into, gaining the simplicity that this sort of diagram buys you without necessarily having to trade off that sort of availability issue is a huge kind of benefit. So the question then becomes, what service should we be using to represent this, right? And kind of the service that we've built at AWS to address this specific need is Amazon EventBridge. So we released the Amazon EventBridge back in July. Prior to that, you may have used CloudWatch Events. That was sort of the predecessor to Amazon EventBridge, and in fact, it uses the same sort of API under the covers. So in a sense, they're the same service in a lot of ways. But Amazon EventBridge is a fully managed, fully serverless event bus service. It's got native integrations with a number of AWS services as well as SaaS providers. It's got a number of downstream targets that you can send events to, and really kind of the goal of this service, the end, the reason for its existence is to make it easier for you to build event-driven architectures. So if you haven't had a chance to play around with it, you're not familiar with it, we could talk a little bit about sort of how EventBridge works. So to begin with, there are the event sources, right? The things that are producing events that you want to consume and route to various downstream systems. So within EventBridge, there's kind of 3 different types of event sources. You can have native AWS services. So this is something like S3, creating an event that a new object was creating, or EC2 saying, hey, here's a new instance that you just started. SaaS applications are also event sources. So we've got a number of different SaaS providers that are integrated with EventBridge. So everything from Datadog, Zendesk, PagerDuty, Segment. We'll take a look at MongoDB here in a little bit. But so these are things like, hey, a new ticket was created in your CRM. That now becomes an event that you can now go and consume within EventBridge. And then finally, your own custom applications, right? And so that's kind of one of the key things that we're going to take a look at today is building custom applications that are sending events via the API. So there's a simple put events API that you can call from your own applications in order to send events from your own code into EventBridge. Now on the other side of the picture are the targets. So these are the services that you want to send events to. So there are a number of different targets. There are over a dozen different targets that you can send events to within EventBridge. I've just kind of depicted some of the most common ones. So these are things like, hey, I want to invoke a Lambda function, or I want to put a record onto a Kinesis stream, whether that's a data stream or a fire hose. I want to start a step functions workflow. I want to put a record onto an SQS queue or notify an SNS topic, right? So EventBridge is going to manage kind of integrating with all of those different services depending on how you've built your downstream services, et cetera. So we've got the event sources, we've got targets, and EventBridge sort of sits in the middle here and helps you get events from one side to the other. And the way it does that is fairly straightforward. It uses the concept of a rule. So a rule is basically just a set of criteria that you can use to match against certain events. And then those rules get associated with one or more targets. So basically what happens is when an event comes in the front door, first thing that happens is we go and evaluate that event against all of the rules in your event bus. In this case, let's say that rule 1 and 3 match. In that case, EventBridge is going to go and forward that original event onto the targets that are associated with those rules. So it's a pretty straightforward, simple model. There's not a whole lot going on there. I think some of the cool things about this, though, is that the delivery side of things, EventBridge is managing that for you. It's going to retry any failures there. You don't have to worry about kind of making sure that the events get to their destination. It'll retry for up to 24 hours if there are any problems with kind of that connection getting to the downstream services. And it provides you kind of this matching semantic where you can write rules based on criteria that are defined within your events. So events define a number of different metadata fields as well as the actual payload themselves. You can write rules against all of those different kind of fields, whether it's embedded in the body of the event itself or something about the metadata. So saying, hey, I want everything from this particular source, right? I can say I want everything from S3, all of the events from S3, and I want to route them to this Lambda function. You could also say, hey, I want to actually look at very specifically only Zendesk tickets that have this specific department ID inside of the body. I'm going to route that to some step functions, workflow, et cetera, right? So it gives you this kind of powerful, flexible matching mechanism, but at the same time keeps it a fairly simple kind of mental model for how to route events between sources and targets. Now, there are a number of other services that you can also kind of consider for using within kind of an event-oriented architecture. And unfortunately, there's not a great sort of simple rule for exactly when to use one versus the other. I would say that typically EventBridge, again, is kind of the service that we've built specifically to address this concept of making it easy to build event-driven architectures. But there are a couple of different kind of dimensions to think about when you're making this decision that we'll talk about that may mean that you need to kind of think about a different service. So the first kind of dimension, though, that I want to talk about here is operational responsibility. So when you're picking a service to manage event routing and manage events in an event-driven architecture, you should consider the operational responsibility that kind of entails, right? So this you need to think about in terms of a continuum, right? So on the one side, you've got EventBridge and SNS, where these are fully serverless services. You provision event bus or you create a topic, and then you just start sending messages to it. You don't have to worry about scaling it. You don't have to worry about additional provisioning of how much memory or how much CPU do I need. All of that's kind of taken care of for you. On the other side of the spectrum would be managing your own Kafka cluster or RabbitMQ on top of EC2. So certainly plenty of customers out there who are doing that and are doing so successfully. But there's a lot more now on your plate. You've got to worry about patching the servers. You've got to worry about managing OS updates, managing platform updates for the software itself. When you need to scale that out, that's up to you. You've got to manage all of that automation and things. And you can certainly do that. We give you a lot of great tools to build those types of services or build that type of automation and manage that. But there's a lot more complexity. You need to think about how many engineering hours is it going to take for us to kind of manage this service compared to using something that's more towards the left side of this diagram. So in general, I would say start off on the left side of this picture, right? Think about how can we use something that's a managed service, and then only sort of move towards the right if you've got a really good reason to do so. So one of those reasons that you might decide to kind of move the other direction is event ordering, right? So in certain situations, depending on the applications you have, you may need well-ordered streams of events. So EventBridge and SNS today do not support well-ordered events, so you're not going to get that kind of FIFO semantic. An event that comes in after another one, from a particular source, the order of those events may get switched at some point as they're being sent downstream to targets. There are a number of other services, though, that do provide that ability to have kind of multiple consumers receiving a well-ordered stream of events. But the thing that I would caution you here is, consider whether or not you really need message ordering. In a lot of cases, if you've got legacy application, if you've got existing code or existing sort of application models that make this assumption, it's really hard to kind of break that. But if you're building a greenfield application, if you're building something from scratch, oftentimes you're going to have to consider, what happens in the error case, right? What happens if I do get an event that's out of order? Handling that gracefully versus just saying, hey, I'm going to throw up my hands and say this is something that I can't deal with, may be worth it in order to get the kind of additional operational benefits and resiliency benefits that you get when you don't care about order. So oftentimes I think, yeah, people assume that, hey, I really need to have well-ordered events. I can't possibly process, an order change event before I get the order create event. But in a lot of cases you can. A lot of times it's actually fairly straightforward to create a partial transaction, store that in a database, and then wait to see, hey, am I going to get the new event? And then create a report, create an operational report that lets you see how many outstanding orders do I have where I kind of missed one of those things, and then you can start kind of driving that, figuring out what the problems were, et cetera. And in a lot of cases, those become much more resilient and robust systems overall. So another kind of dimension to make sure you're considering is kind of the pricing, the cost models of these different services. So EventBridge, as an example, has a pretty straightforward model. So you pay per event that comes in the front door of your event bus. It's $1 per million events. You don't pay anything for the downstream delivery. You're only paying for kind of the events that you send to it, and you only pay for the custom events that your apps send or that you receive from SaaS applications. Anything from a native AWS service is free. For Kinesis data streams, that's a little bit different model. You're paying both per shard hour as well as a charge per what's called put payload event, which is basically a chunk of 25 KB of data that you're sending into the stream. So these two, the dimensions of this cost model are different, and so it's kind of hard to kind of reason about. So I think it's useful to look at a couple of concrete examples. When you're at the really low end of the throughput rate, right? So let's say we're doing 1 TPS constantly across the month, then neither one of these are really going to break the bank. You're not really paying a whole lot. It's probably not worth thinking about this decision too much. Even when you start ramping up, you're up to, say, 40 TPS, which is a fairly significant amount of messages, actually, when you think about the fact that this is running continuously 24/7 for an entire month. That's around 100 million events a month, which, again, depending on the domain we're talking about, depending on your use case, that's a fair amount. Even still, EventBridge is now starting to get a little bit more expensive, but still probably not kind of worth the extra effort to really go and optimize for cost at kind of this level. However, once you start getting into really high kind of throughput use cases where you're doing 1,000 events every second, constantly throughout the month. So maybe you've got an IoT use case, you've got sensors that are all spread across the world, sending back these little tiny packets of data constantly. Those are kind of the use cases where you need to consider, is EventBridge the right model, or at the very least, make sure you understand the costs that are going to be associated with that. Oftentimes, I think when you start to get into these types of scenarios, so that IoT use case that I described, you need to figure out, are you really doing an event-driven model at that point? Are these records that are coming in the door really events that you need to be responding to? Are you taking action based on those, or is this really a data ingestion problem where you just need to sort of aggregate all of these records and then do something with them on the back end, right? So moving into a model maybe where you have Kinesis on the front end to kind of pull all of this data in, get it aggregated, get it into S3, and then potentially do kind of windowed analytics on it to determine, hey, is there something interesting going on, or is this all what I expected? And then creating sort of events, synthesizing events based on that then go into a more traditional event-oriented architecture might be a better sort of solution when you sort of run into these kind of things. So the last kind of piece of this that I want to talk about is the integrations kind of aspect, right? So one of the things that I find customers also often end up doing when they start to get a lot of different sort of distributed components is you end up with kind of this heterogeneous, mix of different systems that you're trying to have communicate with one another, and you end up with a lot of different sort of glue pieces and agents and little Lambda functions that are doing nothing more than kind of gluing pieces together. And I think that's one of the really important things to kind of recognize and see, are there ways that you can get out of the business of managing kind of that glue code, right? So with EventBridge, again, we already talked a little bit about sort of what the event sources look like. You can integrate with SaaS applications as well as your own applications, et cetera. Same thing kind of with the downstream services. If all you're going to do is take an event and stick it into a fire hose so that it can go into S3, there's probably not a lot of reason to have a Lambda function sitting there to kind of do that. So, using a service that can go and kind of integrate directly with the downstream targets that you care about is going to save you a lot of kind of just overall complexity and management that you would otherwise need. And then what this allows you to do is now start to do things like, okay, what if you need operational logging? I want to have a log of all of the events that are going through my system, or maybe there is some specific set of high priority events that you want to make sure that you've got a log for. You can do that with EventBridge, right? You can set up a rule that sends all of those specific events that you care about to a CloudWatch log stream, and this is really, really powerful. I would very much encourage you, if you're building things like this, make sure that you've got some mechanism to get visibility into what that stream of events look like from both just kind of an overall monitoring perspective, as well as being able to go back and debug things in the future. This is really powerful. Another kind of approach to that you may do both of these or one or the other is having a fire hose that dumps things into an S3 bucket, then using Athena to be able to go and query against that. Hugely powerful. So getting back to that kind of concept of, hey, why is account 123 in this particular state? Being able to go and look that up. Oh, let me just go and search all of the events for this particular customer ID and figure out everything that's happened over the last week. Really, really powerful tool to have, and it's extremely easy to implement here with EventBridge. It's literally one rule with a specific target that you configure there. So, okay, so now we've picked an event router. You're going to set this up. The question then becomes, how many of these do I need? How should I be organizing all of my different services? Should they all be using one or more? And in order to kind of talk about this, it's important to understand the types of event buses that exist within EventBridge. So first of all, you've got the default event bus. So every single AWS account has a default event bus associated with it. This is where all of those native AWS services are sending their events. You don't really get to change that. You can't remove the default event bus. You can't change where those native event sources go. You can also, though, create custom event buses. So a custom event bus, you can send data to using that put events API that I referenced previously. And then there are also partner event buses. So these are when you've got SaaS applications that you want to receive events from. You have to create a separate event bus per SaaS application, per SaaS integration that you've got. And so, yeah, and that's how you configure the SaaS events. So the decision point here really kind of comes down to how many custom buses do I need? You're always going to have the default event bus. You're always going to have one SaaS bus per integration. So the question is how many custom buses to do. And you can kind of have two different extremes. On one side, you could say I'm not going to have any custom event buses. On the other side, you say I'm going to create a separate custom event bus for every individual producer. The right answer is probably somewhere in between here, but the key thing that you don't want to do is you don't want to end up creating event buses per consumer and forcing your producers to then route between those on the producer side. So keeping routing logic out of the producer is one of the kind of core tenets, I would say, of building event-driven architecture successfully. So make sure that you avoid doing that. The way that I typically encourage customers to kind of think and reason about this is try and align your event buses along sort of those domains that we talked about previously, right? So typically you're going to have a number of different domains. They typically are going to have various kind of security constraints. You may have more sensitive data versus less sensitive data. You may have certain data that has different kind of, again, operational logging requirements and things like that. And so you want to kind of organize things around those kind of concepts because yeah, it's going to make it easier for you to apply different policies to those buses and implement the kind of cross-cutting concerns that we talked about previously. So once you've kind of decided on how many buses you're going to have, what does that kind of architecture look like? The question is, how do you provision these? So when you've got sort of shared buses that are being used across multiple different applications, you've got multiple consumers that are going to be consuming events from a single bus. It typically makes sense to have a shared services stack, if you will, right? So each of these kind of boxes you can think of as being representative of either a CloudFormation stack or maybe a Terraform module, some sort of infrastructure as code unit that you're deploying independent of one another. And the nice thing about EventBridge is you can create an event bus in one stack, and then you can actually reference that and create the rule resources in a different stack. So rules are a separate resource from the bus themselves. So you can go and create those inside of the actual consumer sort of application stacks and associate them with your sort of centralized, standardized event bus. And that typically makes it much easier. The consumers can define specifically which events they're interested in receiving, apply that to this shared event bus, and off you go. Now, that model that I just showed you works when we're talking about a single account, but it does not work when you've got multiple accounts going on. So if I'm in one account, I can't create a rule on an event bus in a different account and send events over to targets that kind of cross accounts, right? So in order to kind of manage this, you might sort of initially think of an architecture that looks something like this. Okay, I'm going to create local event buses in each of the consumer accounts and then have the producer send to both of those. But this kind of violates that rule we talked about previously, right? So you've got now kind of the producers responsible for talking to multiple event buses. We don't want to do that. Instead, what you can do is you can put an event bus in the producer account. And then what you can do, the one type of cross-account rule that is allowed is to send an event from one bus to another event bus in a different account. And now those consumers can control exactly how they want to consume events from that local event bus in their own account. Do be aware that when you send an event from one bus to another, that does count as an additional kind of custom event, so that's part of your cost model. So just be aware of that. But overall, this architecture works really well for kind of coordinating across multiple accounts. One other kind of sort of pattern that I've seen start to emerge a little bit, that I've seen some success with customers as they're sort of moving into this model from a more traditional monolithic environment, is taking an existing monolith and kind of applying the strangler pattern to it, right? So we're going to start trying to break apart this monolith that maybe lives on-prem or lives in some other existing environment. Typically, in those types of cases, the database for that monolith is a great source of events. And so you can actually set up an event generator that's going to synthesize events based on what it can pull out of that database. So maybe it's pulling the database in order to get those. It may be using a change data capture type protocol to stream events into it. And then from there, it can create events and put those onto an event bus. And then on the back end, you can go and build more modernized microservices architecture on the back end there. And then similarly on the return trip, creating events that then get persisted back into that database via another Lambda function or other service can kind of let you close that loop. So this is something that's been written about a little bit. Forrest Brazil has a great kind of blog post on this that actually predates EventBridge. He wrote about this when it was still CloudWatch events, but it's a great read. I would encourage you guys to go check that out. All right, so the last kind of topic before we jump into to kind of the demo and getting hands-on with this is structuring events. So what goes into the event payloads themselves? And there's really kind of two different sort of models that you can think about. One is, I'm just going to tell you the facts. I'm just going to tell you, who, what, and when did this happen, right? An order was created. It was created at 10:47, and it was done by this particular customer. But I'm not going to tell you all of the details of the current status of the order and what was in the order and all of that kind of stuff, right? On the other hand, you can have your event include all of that additional kind of detail about the order itself. And what this does is that prevents people from needing to go and kind of, look up the additional state. But at the same time, you need to consider, what happens if this, event on the right side is delayed for some reason, right? What if there's a failure and your service is down for an hour and it comes back up and now it's sort of reading old stale events? You need to make sure that your consumers understand kind of the age of the event, understand the data freshness and whether or not they need to be going and kind of checking to get the latest, greatest state of the system before acting on that. And typically you want them to do that. Typically you want the consumers to go out and make sure that they understand what the current state of the system is, not just what the state of the system was at the time that the event got triggered, because something may have changed. Now, that being said, the thing you got to be careful about is when you start implementing systems that way is you can actually basically turn that into a reflection attack on yourself, right? So you got to make sure that you understand, how much load is that going to generate on the source system if you've got a bunch of people coming in and querying that before you implement that. So once you've kind of built all these great event-driven architectures out, and you've got all of these event producers sending events in different types, the question then becomes like, how do you manage all of those different events across your environment? You've got a bunch of different event types, a bunch of different schemas that those events might follow. How do you figure out what is where, and how do I kind of consume these? That starts to become an interesting challenge. And so in order to address that kind of issue, we just launched on Monday Schema Registry and Discovery. So this provides you with the ability to define schemas for the events that are flowing through your event buses. You can explicitly publish these schemas or discover them. Has integrations with IDEs as well as language support for Python, TypeScript, and Java. And so this is really now a great tool that allows you to go and reason about the events that are in your environment, and organize those in a way that is more easily consumable by development teams. So using Schema Registries itself is free. If you use the auto discovery feature, which we'll take a look at here in a second, there's a free tier there of 5 million ingested events. After that, there's a 10 cent per million fee on top of that for additional ingested events. Typically, we expect that you're going to use this in your development environments to kind of discover schemas there. So the majority of use cases, I think, will fit within that free tier. But there are a couple of cases that we'll talk about as well where you may want to turn this on kind of in prod and kind of monitor all of the different schemas that are flowing through there. So this is available today. You can go and play with this right now. It is currently in preview and available in the following regions that are up there, but it should be available in everyone's account to go and play with today. So let's go ahead and take a look at how this works. Let me wake up my computer here. All right, let's see if this will work. All right, there we go. Okay, so this is the EventBridge console, and if you go over into the left nav now, there's this cool schemas section that you can take a look at, and you'll notice that once everything gets loaded, that there are now a bunch of schemas that are going to show up. So this is what you're going to see when you log in as well. All of the sort of native AWS event sources have schemas that are published into your schema registry already. But you can also go and create your own custom registries, right? So I can go and create a registry, we'll call this demo, and create. And then once I've got a custom registry created, I can create a schema. I can add it to this demo registry, we'll just call this example. And now I can go in and create this actual schema. This is using the Open API 3.0 schema specification. Standard kind of JSON schema stuff. So you could go in and write a JSON schema spec directly, or you can even go in and create, give us a sample event. So we'll, put something simple in here for now, but you give us any kind of JSON and discover that schema from there. So currently this supports JSON explicitly. It's using Open API spec. I think definitely the idea is that long term we'll look at other types of event payloads and different formats. So that's definitely something we're interested in hearing feedback from everyone about. What types of formats are you using to communicate between your systems. So you can see here, discovered this schema. It can show you that you've got this field. It's of type string. It's required in this particular case because the example I've given it has that field filled in. And I can go ahead and create that. Now the really powerful part about this is that now I can go in and search for things. So I can search for the name, of that schema that I created, if I can spell it right. I think I had a typo in that. So anyway, I can search for the name, but I can also go and search for individual fields, right? So I can go and say, hey, I know that there's some events that deal with customer ID or some other kind of term, and I can go and search through my events for or through all of the schemas specifically for those fields as well. So that becomes a really powerful way to go and discover what events are even available for you to start consuming and writing applications against. One of the other great things that you can do is you can download code bindings for this, right? So you can actually download generated classes for these different languages that you can then go and ingest into your IDE, which we'll take a look at here in a second. And then the last piece of this is, so I showed you how you can go and manually create manually create schemas, but most of us aren't going to actually go and do that, right? Like those are the types of tasks that always end up sort of slipping down to the bottom of the backlog. They fall off the end of every sprint. That kind of housekeeping is just not as fun as actually going and writing the code. So instead of doing that, you can actually go in to an event bus. So in this case, I've got this demo event bus. And you can see right now, there's this new field called Schema Discovery that is not currently initiated for this. Click that button, turn that on, and now what this does is it creates a new rule on this event bus. I'll go and take a look at that. So we talked about rules being kind of on event buses. All this is doing now is creating a new rule that's saying, hey, I'm going to go and grab all of the events for this account and send them now down to this managed event bus that the EventBridge team owns that then does schema discovery automatically for all of the events that pass through that event bus. So to kind of look at how this works in practice, I've got this little demo application here. So this is a simple kind of e-commerce type site, right, that supports reviews. And you can see some of the reviews are not so positive, right? And maybe let's say we want to set up an integration with our CRM so that anytime someone posts a negative review, we want to create a new ticket in our CRM so that someone can follow up with them, figure out exactly what was wrong, and try to improve that customer experience. So right now, the way that this site works, the architecture is pretty straightforward. Basically what happens is we've got a web application that calls an API, hosted an API gateway, hits a Lambda function, then we're storing this in a MongoDB database that's hosted on MongoDB Atlas. So this is a hosted database as a service offering from MongoDB. And the cool part about this is MongoDB Atlas is actually integrated with EventBridge. So they can send events directly to an event bus in your own account, just like a number of other SaaS providers can as well. And so basically what we're going to do now is we're going to build the kind of next piece of this, which is, okay, we're going to consume this event that comes from this database. We're going to write a Lambda function that consumes that event. It's going to call comprehend to determine whether or not the sentiment is positive or negative, and then create a ticket in Zendesk in the event that it's a negative kind of review. So I've already set this piece of it up. We've already done the schema discovery. So if I jump over now into my IDE, I've already got the AWS toolkit installed, and the latest version of the AWS toolkit has support for event schemas. So I can go in here, I can see this demo that I just created. I can also see the discovered schemas here that have already been done. So there's this new schema definition that's been discovered. So I didn't write this. I don't have to write any of the JSON schema code to define this. This is entirely defined because there have been events flowing through that event bus, and EventBridge discovered the schema for me. And now if I want to, I can say, okay, well, let's go ahead and create a new project here. And I'm going to use, again, the AWS toolkit to create a new serverless application. And now there's this new option here in the SAM template to say, I want to create an EventBridge app, right? So let's see if I can select the right one. So I'm going to create this EventBridge application. And now I get to go and select the schema that I want. So I'm going to go and select this discovered schema that it's created for me. And go ahead and finish. We'll use this window. And now it's going to go out and it's going to generate kind of this boilerplate code for me that allows me to consume these events really easily. So it creates a README. It also creates this SAM template that has let's see if I can make that a little bigger, has a Lambda function defined in it that is connected up to EventBridge. CloudWatch Events in this case is just sort of the legacy name of EventBridge. So it's connected up for you already. And not only does it create this SAM template for you, it also creates the source code that you need in order to ingest and unmarshal the event, right? So it's got a handler already defined. It's going to take the input, the raw JSON, unmarshal it into a strongly typed object, and then gives you this kind of handy place where I can start writing my own code. So now I can immediately go in here. I'll delete that and just start saying detail. Get full document. So again, this is a MongoDB thing. It's got some metadata about the event itself, as well as then the actual full document that was stored. So if I get the full document, now I can go and see all of the other stuff that was on there, right? So I can see when it was created, I can see the description. So the description is kind of the actual review that was written. I can see the star rating, etc., right? And so all of this is kind of strongly typed. I'm just control spacing to get all of this kind of information. So now in order to kind of implement, again, this architecture that we talked about, so I want to be able to talk to Comprehend. I also want to be able to talk to Zendesk. I need to make a couple of quick kind of updates to my build file one. So I'm going to add some dependencies here real quick just to be able to talk to Comprehend, be able to talk to Zendesk, this kind of standard boilerplate stuff that you do with Java. Then I'm also going to go and add into my template permissions here, right? So I need to give it permissions to call Comprehend. I'm going to give it permissions to call SSM as well to get parameters to configure my Zendesk connection. And so now I should be able to come back into my application. Let me make sure it imported everything correctly. Yeah, I'm sorry. There's a problem with my Gradle config for some reason. Real quick, let me auto import and apply. Save that again. Okay, so now I've got all of the dependencies that I need. So we'll come back over to the app. So I wrote a little bit of code already that will actually just give us some kind of helper methods here. So basically all this is doing is giving me this Comprehend client as well as the Zendesk pieces initialized, and for some reason my dependencies are now not. Live coding, the joys of doing live demos. So yeah, sorry about this. Let me try this one more time. So yeah, I think everything is in here that I need. I've got the Comprehend client, etc. Let's open this up and try this one more time. Darn. Okay, so let me switch my workspace. This one hopefully will work correctly. Okay, so here's basically the same thing. I just had kind of a previous version of this that I had already built. So let's go and take a look at this application code. And so basically what I've got here is this method to detect sentiment using Comprehend and then create the Zendesk ticket itself. And then there's also this method for building the Zendesk client. But again, this is all pretty straightforward stuff. And now I've got my business logic as well. And the big piece, the killer feature, I guess, for this feature is that I've got this now generated code, so I can come in here and start doing these kind of strongly typed things. I can control space. I can get the description. If you forget whether or not stars is a string or an integer, that's going to be able to give that to you really easily, right? So I can do reviewed, I get star rating, realize that, oh man, this is, I thought that this would be an integer, that would make sense, but it turns out the developers actually are encoding it as a string. And so I'm going to need to parse that first. So, okay, that's fine. I'll do integer to get value of, and do that. And so now that I've got all of this developed, I can come back down here to my template, and I should be able to just deploy this into my account. So let's see if we can make this work. So we'll create a stack. We'll call it schema demo. And then I'm going to use this existing S3 bucket that I've already got in my account. But overall, the plugin should kind of just handle doing the deployment for me. It's going to go out. It's going to build my application. It's going to compile my Java code, create the jar, get it all ready to go. So this will take just a second for it to kind of upload everything into S3 and then do the deployment. And so while we're waiting for that to complete, first of all, I can show you real quick in Zendesk, right? So this is kind of our goal here is hopefully there's not a bunch of tickets in here already. Yeah, so right now I don't have any tickets in here. There's no unassigned tickets, etc. We'll go ahead and create, a new review. Say 1 star and say, this was awful. Right? I'm very upset. very upset. Right, so let's go check real quick. Okay, it's still creating. One other thing that I wanted to show you, so I mentioned that the free tier is 5 million events. We're expecting that typically you would enable schema discovery in your development environment, probably not in your production environment. However, there are some use cases that we think might be interesting where you might want to turn this on in production. And one of those is if you want to detect when a new schema exists, or when a new schema gets created, right? So, hey, I've got an application that's been sending events with this one particular schema, but now that application changed unexpectedly, potentially, right? And I want to be able to detect, hey, when are these applications, sending me new fields that I didn't expect before? You can actually turn on schema discovery and have it kind of constantly watching that stream of events. And then schema discovery itself now is an event source that will publish events into your own default event bus. So now every time a new schema is discovered, that's going to get published onto your default event bus. You can hook up a rule to send that then down to a Lambda function or to something else that can alert you to say, hey, there's this new schema now published. You need to be aware of that, right? Maybe that's a problem, maybe it's not. But it gives you kind of that ability now to detect when new schemas are created. And I think this is a really great example too of one of those kind of cross-cutting concerns. So you can just turn this on within your event bus. All of the events that are flowing through are going to get kind of shoved down into the schema discovery. And then also continuing to chain that down, having more services now that you can use to kind of trigger based on events and build these kind of relatively complex architectures in a way that's super robust and easy, because each of these kind of components takes an input, creates some events, and allows you to subscribe other downstream services to them. So let's go back now and take a look to see, okay, cool. So now we've got create complete. So at this point, I should be able to go in and submit my review. So we'll submit this and then see if it gets saved, hopefully. There we go. So now it's there, and we'll come back over here. Hopefully, if I refresh, be able to see it. There we go. We've got one new ticket. This will update. Oh, okay, there you go. So now we've got this ticket. We've got it created in Zendesk. And so, with about, 100 lines of code or so, like I copy pasted in a little bit of that, but I mean, there was 15 lines of business logic, if that. All of the other code was kind of generated for me automatically just based on observing how my application was already working, right? So building those types of applications, being able to kind of leverage the existing events that are in your system and then build applications very, very rapidly, get them deployed and kind of build out these integrations is exactly kind of the pattern of development that we're trying to enable with this. So I really hope you guys will check this out. Like I said, the new schema registry and discovery is available to everyone. Please go check it out. Let us know what you think. I will be up front for a few more minutes. If anyone's got questions that you guys want to talk about, I'm more than happy to answer those. And if you could take a few minutes, or not even a few minutes, 20 seconds to just open your app, let me know what you thought about this session. Fill out the survey. Would really appreciate it. Would love to hear what you thought. And yeah, thanks again, everyone. Have a great rest of your conference.